Tonight, we're climbing through the slow heartbeat of the Earth itself, the mountains. We'll explore how they're born from the clash of continents, how they shape the wind and rain, and how life manages to survive where the air thins and the stars draw near. You'll hear stories of hidden peaks beneath ice, volcanoes that grow in a single lifetime, and mountains that exist on worlds far beyond our own. If these peaceful journeys help you unwind, I'd love for you to subscribe and join us again. And tell me, where in the world are you watching from tonight? Now, take a deep breath. Feel the weight of the day fade, and let the mountains rise quietly in your mind. Far below the surface, continents drift like rafts upon molten rock. When they meet, the collision is slow but unstoppable. Over millions of years, the crust folds, buckles, and rises until the flat seabed becomes a wall of stone. The Himalayas were born this way, India pressing into Asia, a meeting of continents still unfolding today. Each ridge carries the memory of that slow embrace, a monument to pressure turned into beauty. Picture two massive icebergs in a dark sea, except these are solid slabs of the Earth's crust sliding on a softer mantle. They don't slam together in an instant like cars in an accident. They inch, scrape, and shove, centimeter by centimeter. That pace is hard to imagine because our lives are measured in minutes and years, but not in the deep patience of geology. To relate, think about how long it takes to grow a fingernail. Mountain ranges can rise at similar speeds, just a few millimeters a year. That tiny growth, stacked up over millions of years, gives us peaks that scrape the sky. When a continental plate meets another continental plate, neither easily sinks. Unlike oceanic crust, which is denser and will dive beneath a continent, continental crust is buoyant. So instead of one plate subducting cleanly, they crumple. Layers of rock fold like fabric, being pinched and then stacked into huge nappies. Sheets of rock thrust on top of each other. Imagine pushing a rug against a wall until it buckles and forms ripples. Those ripples are the folds and thrust faults geologists map across mountain belts. Each fold is a chapter in the story. Older layers can be forced atop younger ones, and rocks that once lay horizontally at the bottom of the sea are now tilted and exposed. The pressure and heat in these collision zones do more than change shape. They transform the rocks themselves. Sediment that once held the fossils of seabed creatures gets cooked and recrystallized into metamorphic rock, schist, gneiss, materials tougher and more beautiful, banded with the stress they endured. If you hold a slab of such rock, you're literally holding the fingerprint of continental pain, foliation lines, stretched minerals, veins where melted material moved. It's a reminder that mountains preserve a memory of violent, patient processes. This memory shows in surprising ways. On the summit of Mount Everest, for example, scientists have found fossilized seashells, tiny, ancient reminders that once this place was ocean floor. Imagine standing on a peak while the stone under your boot carries the ghosts of tiny marine creatures. That's one of the most humanizing facts about mountain birth. What looks eternal has a history, and that history is written in layers we can read. The collision is not a one-off event. India didn't bump into Asia and stop. It keeps pressing forward, driving up lift and occasional earthquakes. Those quakes, sudden and terrifying to anyone who feels them, are just a short-term release valve for the enormous stress that builds over long stretches of time. Scientists use GPS to measure how fast mountains are rising, often only a few millimeters per year. But those measurements link what we can feel, an earthquake, a landslide, with processes that reshape continents. There's also a balancing act called isostasy. The thicker the crust becomes, the higher it floats on the denser mantle, much like a heavier stack of books will make a foam raft sit lower unless it's buoyed by something beneath. As material piles up and the crust thickens, it pushes the surface upward. Erosion, though, is also at work. Rivers, glaciers, wind wearing away the peaks. That seems destructive, but it's part of the same story. Erosion strips weight from the mountains, and the crust can rebound and rise further. The tallest ranges you see are in part a product of both uplift and endless abrasion. How does all this affect us? Mountains born from collisions sculpt weather patterns, guide river systems, and create unique ecosystems. They demand respect because their slow birth can produce sudden violence, avalanches, landslides, earthquakes that impacts millions of people. But they also give us water, fertile valleys, and raw beauty. When you look up at a ridge, remember it's not only stone and snow, it's a record of pressure, patience, and persistence. Each line in those rocks is like a scar or a laugh line on a face, evidence of a life lived under strain. So the next time you stand at the base of a mountain or watch a jagged skyline, try to imagine that gradual, relentless embrace beneath your feet. The mountain didn't appear overnight. It's the visible outcome of plates that kept moving, sometimes with gentle insistence, sometimes with violent release. That long process takes the anonymous force of the earth and turns it into a place we can touch, climb, or lose ourselves on. A monument to the idea that pressure, maintained over time, can create something unexpectedly beautiful. Think of standing at the lip of a canyon and watching dust motes drift through a shaft of sunlight. It feels slow, almost painfully slow, like watching a clock tick once every minute. But that slowness is the drama. Wind, rain, and ice are patient sculptors. They nibble away at rock grain by grain, drop by drop. Each tiny act of weathering and transport seems insignificant on its own, but multiplied across centuries and mountain chains, it reshapes the world. Now imagine beneath your feet, deep in the crust, another kind of insistence. Heat from Earth's interior and the shoving of tectonic plates are constantly doing something different, pushing, thickening, lifting. It's like someone under the earth is steadily adding layers to a foundation, pressing upward with a quiet, unstoppable weight. Those two forces, the upward push and the surface wearing, are locked in a race. Sometimes the ground gains, sometimes the sky wins. Most of the time, it's a messy standoff. When I first started hiking in high places, I thought mountains were permanent, unchanging monuments. Then I learned to look more closely. Talus slopes that have grown since last winter, stream beds that cut deeper after a big storm, ridgelines that seem subtly different from one season to the next. That's because mountains are never truly static. Every summit is a snapshot of an active contest between uplift from within and surrender to the outside world. Take the Andes as an example, a place where the balance tips often in favor of creation. The South American plate is being squeezed by the oceanic Nazca plate plunging beneath it. That collision doesn't just lift crust up, it thickens it. Imagine squeezing clay with your hands and watching it slowly mound up. In some parts of the Andes, the crust is thick enough that the whole landscape is rising at measurable rates, millimeters per year. That sounds microscopic, but when the rise keeps up with, or outpaces erosion, valleys and peaks get a chance to grow taller and more rugged. Entire drainage systems find themselves chasing an ever-lifting floor. Contrast that with a river that's been given a job it will never complete, carving a valley that keeps rising. Rivers are remarkable engines of erosion. They scope out the easiest routes, pick at weak points, and over time can gouge deep, narrow gorges through bedrock. But if the land beneath them is being lifted faster than they can cut, they start to look like they're running on a treadmill, frantically racing, but never gaining ground. You can see this in the steep, incised river canyons of uplifted mountain belts, narrow, energetic, with waterfalls and rapids where the river suddenly meets rock that hasn't given up yet. Glaciers do something similar, but with a different kind of muscle. Where ice forms and moves, it acts like a slow conveyor belt carrying away rock. Glacial plucking and abrasion carve U-shaped valleys and polished rock faces. During colder climates, glaciers can beat rivers at their own game, carving entire valleys into very different shapes. Yet glaciers are climate dependent. When the climate warms and ice retreats, river processes take over again. It's a dance of dominance that shifts with the mood of the atmosphere. I like to think of uplift and erosion as a bank account and two people making withdrawals and deposits. The mountain makes deposits into elevation when tectonics push up, and the sky, the weather, makes withdrawals every time a drop of rain loosens a grain of sand or a gust of wind pries a flake of rock free. If the depositor is generous, fast uplift, the balance grows. If the withdrawer is relentless, heavy rains, strong seasonality, powerful glaciers, the balance shrinks. Where they roughly balance, the landscape reaches a sort of dynamic steady state. Peaks remain high, rivers carry sediment endlessly, and the slopes keep their characteristic shapes. But even that balance is temporary. A change in climate, a shift in plate motion, or the sudden removal of a glacier can tilt the scales. That dynamic is visible in how valleys and summits behave. In some places in the Andes, entire valleys appear to be struggling to keep up as the crust thickens below. Channels steepen, sediment flux increases, and landslides become more frequent because the system is straining under two contradictory impulses. The ground wants to rise, the sky wants it to wear down. Those steep, abrupt valley sides tell a story of competition. Streams working overtime to carry rocks and soil downslope, while the land beneath keeps trying to present them with new rock faces to cut into. But erosion doesn't just remove material. It also exposes new surfaces to further weathering, alters drainage patterns, and can even influence the tectonics themselves. As rivers strip away weight from mountain fronts, the crust responds by rebounding, a principle called isostasy. You can imagine taking away bricks from the top of a diving board and watching the other end spring up. In the very long term, that removal can localize uplift, making some places more prone to continued mountain building even as they are being shaved down. There's also a humbling human parallel here. Think about how we age. Some people seem to collect experiences that add a kind of emotional uplift. They grow in wisdom, stature, influence. Others are worn down by constant stressors, the daily grind, illness, heartbreak. and often both things happen at once. You can become more resilient and yet more vulnerable in the same years. Mountains are no different. They gain height and expression in one sense, and in another sense, they are patiently deconstructed. Standing at the summit or the valley floor, you are witnessing an archive of pressures and patience. The rivers that cut narrow gorges are especially poetic to me. They never really win in the sense of finishing the job. They only ever progress until the conditions change. They remind me of people who set out to fix something that's fundamentally unfixable, like trying to hold back the tide, but whose dogged persistence causes profound, lasting change anyway. A river doesn't have to outclimb the uplift to be significant. By cutting a gorge, it reshapes ecosystems, influences where people can travel, and leaves a dramatic record in stone. Water can be the patient artist that writes a landscape's biography in layers. And then there's the image of every summit as a balance point, a fragile, transient victory. For a climber, reaching a peak feels definitive. For a geologist, that same peak is just a moment in a long saga. The summit exists because uplift exceeded erosion for long enough. It survives as long as that balance holds. But a storm will come. A freeze-thaw cycle will pry something loose. Vegetation will find a crack and widen it over decades. The summit holds its form because of the strength of the rock and the slowness of the sky's work. But neither is absolute. To stand on one of these summits is to feel both the solidity of stone underfoot and the epic patience of weather pressing from above. It's to be privy to a conversation between forces operating on different timescales. The sudden, human-scale events like landslides and floods, and the slow, almost imperceptible motions of plates and ice. Every landscape is a palimpsest, written by that conversation, layers upon layers of making and unmaking. There's comfort in that too. It means even the most imposing forms are not frozen monuments, but elements in an ongoing process. The mountain you see today was forged by pressures that predate human memory and will continue shaping long after we're gone. Yet because these changes happen within timescales, we can intuit a flash flood, a season of heavy snow, a decade of uplift. We can sense the rhythms and relate them to our own lives. We can appreciate both the stubbornness of stone and the patience of the sky, and in that appreciation find a kind of companionship with the yawning, grain-by-grain artistry of Earth itself. But mountains aren't the immovable monoliths we often imagine. They travel. Not like animals or people, you wouldn't see them packing suitcases, but slowly, quietly, across hundreds of millions of years, riding on plates of the Earth the size of continents. That idea takes a minute to sink in. It did for me the first time I held a fossilized shell on a ridge in the Appalachians and realized I was standing on the floor of an ocean that no longer exists. Picture the Appalachian Mountains as they were 500 million years ago. Warm, shallow seas teeming with life, sunlight slanting into water, rich with coral and tiny shelled creatures. Over time, sediments piled up and buried those creatures, turning them into stone. Then continents drifted, collisions happened, mountains rose, eroded, and rose again. The rocks that now form the Appalachians were once at the equator, kissed by tropical currents. That's not poetic license. That's plate tectonics. The fossils embedded in those rocks are the receipts. I remember hiking a quiet trail in western Pennsylvania on a late summer morning. The path climbed steadily, and every few steps the shale and limestone underfoot told a different story. Ripple marks like miniature dunes, the faint imprint of a shell, a cluster of brachiopods glued in place like tiny armored flowers. I picked one up. It was light, brittle at the edges, and held it against the sky. In that moment, the mountain stopped being an object and became a narrative. The little shell was a witness. It had once filtered food in warm seawater, been buried, lithified, squashed, heated, uplifted, and, eventually, exposed again. The mountain was not simply here, it had been somewhere else, and it had been through things. The mechanics are elegant in their simplicity. Imagine the Earth's surface as a cracked eggshell. That shell is divided into plates. Those plates glide, collide, and pull apart over geological time. When two plates converge, their edges crumple and fold, and rocks that once lay on the bottom of an ocean can be shoved up into a mountain chain. When they pull apart, new oceans form. And because the plates themselves move, sometimes carrying entire continents, mountain ranges go along for the ride. The Appalachians, for instance, were part of ancient collisions that assembled continents into supercontinents, like Pangaea. When those blocks later drifted and reconfigured, the entire range migrated northward. It helps to think about scale in familiar terms. Tectonic plates move at rates comparable to the speed at which your fingernails grow. That's a slow motion, imperceptible day to day, but relentless over eons. Put a watch on that scale. A mountain can cross latitudes in the time it takes for life forms to evolve, for climates to shift, for forests to change from swampy, coal-producing wetlands into the temperate woods we hike through today. The Appalachian rocks preserve that timeline. Corals and shells in high, cold ridgelines are a kind of time capsule, proof that the climate and the continents themselves have been mobile. There's a humility in that realization. Standing on a ridge, you're not only looking across a landscape, you're standing on a traveler that has experienced seas, deserts, collisions, and slow, patient nudges. That perspective changes the language you use. Instead of saying this mountain, I find myself saying this traveler, or this ancient road. It makes the hills less like static scenery and more like characters in a story, complete with origins, journeys, and scars. Those scars are legible if you know where to look. Folded layers of rock, jagged contacts between different strata, and fossil assemblages that shouldn't be where they are all hint at past motion. On a steep slope you might find limestone, once the sediment of warm seas, cracked and tilted beside sandstone that formed on a shoreline. Each contact is a chapter break. Geologists read these like detectives. The orientation of layers tells them which way a mountain rode, the types of fossils tell them which climate it experienced, and the minerals tell them about pressure and heat along the journey. And it's not just the Appalachians. Think of Greenland's ancient rocks that once shared an origin with Scotland, or the mountain chains in Scandinavia that used to be adjacent to eastern North America. The world used to look like a different puzzle, and mountains are the edges that sometimes end up very far from where they began. You and I, standing in an alpine meadow or on a rounded Appalachian knob, are occupying the same real estate as shells that filtered water in a Paleozoic sea, or as sand that once lay on a beach near the equator. This traveling quality also reshapes how I experience weather on a hike. when clouds roll in and the wind turns cold, there's a flicker of cognitive dissonance. The rocks underfoot remember a warmer time, yet the air around me is bitter. It's a reminder that landscapes carry layered memories of climates that are now gone. When I kneel and press my palm to a fossil, I like to imagine how many seasons have passed since that organism lived. How many monsoons, how many suns. It reduces the small urgencies of daily life to a manageable hum. Problems still exist, of course, but they're more of a single breath against geologic patience. Sharing this with people on the trail always sparks something. I've had strangers, parents carrying kids, weekend hikers, retirees, pause as if hearing that piece of history for the first time. They crouch, they touch a rock, and their conversation changes. Instead of talking about mileage and elevation gain, they wonder aloud how a sea could end up where spruce now grow. That curiosity is a beautiful connection. It turns a simple outdoor excursion into a lesson in time travel, and it makes the mountain personal again. For all their slow motion, these migrations have consequences we feel now. Mountains influence rainfall, create rain shadows, guide river paths, and determine where soils accumulate. As ranges rise and erode, they feed rivers with sediments that build valleys and deltas far away. A traveler mountain thus becomes an architect of the surrounding landscape, shaping ecosystems and human lives. The Appalachian sediments, redistributed by rivers over millennia, helped form plains and provided resources that supported communities. The mountain's journey is also a story of giving. So next time you lace up your boots and head for a ridge, carry this image. You are not just climbing a pile of rock. You're stepping onto an old traveler that has crossed oceans. Look for the fossils, trace the folds in the rock with your fingers, and let the idea linger that beneath your feet is a record of movement, of seas that once were, of collisions that raised continents, of a world that rearranged itself. There's a strange comfort in this mobility. If the land itself can move and change, maybe our own journeys are part of the same flow. We are, after all, passing through on a mountain that has already known many routes. Slide your imagination beneath that endless white, and you'll find something almost impossible. A mountain range as grand as the Alps, completely invisible to us. The Gamburtsev Range sits under miles of Antarctic ice, peaks buried so deep that no human eye has ever looked upon them. Think about that for a second. There are giants folded into the planet that we can only know by the echo of sound waves and the tremble of the ground. It feels like discovering a secret city under the floor of your home. Everything you walk over was shaped by something you can't see. When scientists first mapped the Gamburtsevs, they didn't use maps like you or I would. They used ice-penetrating radar and seismic surveys, listening for reflections and murmurs that tell you what rock looks like when it's been sleeping for tens of millions of years. Those instruments let us hear the contours of mountains hidden for 30 million years, older than the human species, older than most mammal lineages. To put that in everyday terms, the mountains beneath Antarctica went to sleep before our grandparents' were even a thought. Their silence has been shaping the continent ever since. Here's the part that keeps pulling me back. Although we can't see these peaks, they govern the slow choreography above. The ice sheet isn't a uniform white sheet sliding mindlessly toward the ocean. It flows in patterns carved by what lies below, valleys and ridges that direct glaciers like riverbeds direct water. Picture glaciers as slow-moving, ghostly rivers, their surfaces glinting under a pale sun, while underneath they're being tugged and guided by hidden roads of stone. The Gamburtsevs are the spine beneath that body, directing ice divides, anchoring ice streams, and determining where the ice will thin or thicken over millennia. That's more personal than it might sound. If you live near a mountain or a river, you understand how a ridge can cast shade, hold snow, or redirect a stream. We decide our routes and build our towns around those features. But in Antarctica, the stakes are global. Those invisible peaks set the paths ice takes as it creeps toward the coast. Where ice is funneled into fast-moving streams, it can more easily reach the ocean and raise sea level. Where the mountains pin the ice down, they act like anchors, slowing loss of ice. So the Gamburtsev Range, unseen though it is, plays a role in the future of coastlines where many of us live and love. There's also a human story in the quiet. I like imagining the teams of researchers camped on the ice, wrapped against temperatures that can bite through gear, patiently laying out radar lines, measuring tiny vibrations from controlled explosions or hammer strikes. They're listening to the planet's whispered history, turning those whispers into a landscape map. That translation, from data to image to understanding, feels like a kind of archaeology. We're digging not with shovels but with math and sound, uncovering the bones of a continent. And then there's the mystery that keeps the Gamburtsevs so compelling. Why are these mountains so well preserved? How did such a large range persist under an ice sheet for so long without being flattened by erosion? Some hypotheses suggest the bedrock is cold and rigid, or that ice coverage protected the range from the forces that wear down mountains. Others point to tectonic quirks long ago that gave these peaks a resilient core. Each layer of understanding raises new questions, which is exactly how I like to imagine science. Less as a list of answers and more as a map of invitations to look deeper. Finally, there's a humbling thought. Landscapes we can't see still shape our world in tangible ways. We often think of Antarctica as a remote white nothing, disconnected from daily life. But hidden beneath that silence are structures that have guided ice flows, influenced global sea level, and written a slow, persistent chapter of Earth's story for 30 million years. That's the kind of hidden complexity that makes the planet so much more alive and surprising than our first glance suggests. And it's a reminder that what we can't see can matter just as much as what we can. Far below the waves lies a world that feels more alien than any planet in a science fiction movie, a landscape of fire and stone, lit only by chemical glow and the flicker of bioluminescence. Most of us picture mountains as peaks under open sky, covered in snow or jagged rock. But the largest mountain range on Earth is invisible to our eyes because it wraps the globe under kilometers of ocean. The mid-ocean ridge stretches for more than 40,000 miles, a hidden seam encircling the planet. And it's alive in a way that's hard to imagine from the deck of a fishing boat or from a beach towel. Think about a moment you've stood by the sea, the endless horizon, the sense that the ocean is deep and mysterious. Now imagine that instead of ocean bottom, you're looking at the rim of a basin that plunges and rises like a mountain range. Along that ridge, volcanic peaks build up from the seafloor. Measured from their base on the ocean floor to their summits, some of those volcanoes are taller than Mount Everest. No sunlight has ever touched their flanks. The peaks are sculpted by basaltic lava and currents, not by wind and weather. That's hard to hold in your head. Mountains we can't see that dwarf everything we're used to. The ridge itself is not a single mountain, but a vast engine room where the planet fabricates new crust. Plates of the Earth pull apart here, and molten rock wells up to fill the gap. As the lava cools, it forms new oceanic crust, a process called seafloor spreading. If you imagine the Earth breathing, this is the inhale, hot, fresh crust pushing outward. On the other side of that breath, old crust returns to the deep at trenches and subduction zones. The exhale. It's a slow, steady cycle that reshapes continents and oceans over millions of years. To me, knowing this changes the way I think about solid ground. The ground isn't static. It's a dynamic skin on a planet with a beating thermal heart. Close up, the geology is beautiful and strange. Where lava pours into cold seawater, it cools instantly and forms rounded pillow-like shapes. Pillow lavas that look like melted bread rolls fused together. Rift valleys cut down the center of the ridge like scars, and transform faults offset the ridge like stair steps. In some places, hydrothermal vents, those famous black smokers, spew mineral-rich fluids into the ocean, creating towers of metal and clouding the water with rust-colored plumes. The chemistry around those vents supports entire ecosystems that don't rely on sunlight. Microbes convert sulfides into energy through chemosynthesis, and complex communities of tube worms, clams, and shrimp cluster around the hot water as if orbiting an invisible star. When scientists first found these vents, it rewired our assumptions about where life can exist. There's also a human story here. For most of history, the ocean's surface was the only part we could really know. But technology changed the game. Satellite altimetry gives us a global picture of the seafloor's undulations by measuring gravity anomalies on the ocean surface. Sonar mapping, submersibles, and remotely operated vehicles, ROVs, have taken researchers down into that dark, cold world. Watching ROV footage is a particular kind of humbling. A camera drifts past towering cliffs of basalt, past vents belching life-sustaining plumes, and you realize these places are gardened by chemistry rather than sunshine. For many of the scientists and technicians I've read about or spoken with, seeing that first plume, that first tube worm, is an emotional moment. A reminder that exploration still exists on Earth, not just on other planets. You can relate to this wonder, even if you've never been near a research vessel. The idea that hidden systems are shaping your world is the same instinct that makes people fascinated by weather, by the way a distant volcano can darken skies, or by how a river can carve a valley you take for granted. Plate tectonics and the mid-ocean ridge operate on scales and timescales that dwarf our daily lives, but their effects are intimate. They build the continents we live on, they drive earthquakes, they recycle carbon and influence climate over eons. In a way, the ridge is the planet's workshop, a place where rocks are created and transformed, and where life has found a foothold in the bleakest places. And there's something quietly profound about a mountain no light has touched. It's an invitation to humility. Standing on a shoreline, you might feel small, but knowing that beneath your feet is an active, hidden chain of mountains that dwarfs our familiar peaks adds another layer of perspective. It reminds us the Earth is not a fixed backdrop to human life, but a living system with processes that continue whether we watch or not. So when you think about exploration next time, about conquering peaks or mapping new frontiers, consider the mid-ocean ridge, a global spine of fire and stone that shapes continents, feeds odd ecosystems, and quietly breathes life into the deep. The greatest mountains on Earth may be underwater, but their story is part of ours. Not all mountains take eons to form. Picture a man standing in his cornfield on a clear morning, listening to the ordinary sounds of rural life: wind in the stalks, a dog barking, a rooster crowing. Then the ground groans. A crack tears open where the soil used to be, and smoke starts to billow up from between the rows. That was the moment Dionisio Pulido, a farmer in Michoacan, Mexico, first noticed something impossible happening under his feet in 1943. Imagine being him. You've planted this land. You know every stone and furrow. You've watched seasons come and go, trusting the rhythms of planting and harvest. Then, in a matter of hours, the earth asserts a new rhythm. Pulido and his neighbors watched ash and cinders spew into the sky, a mushrooming cone rising where there had only been corn. Within days, a volcanic vent had pushed itself up through the soil and began to grow into a mountain. People in nearby villages compared its suddenness to the most dramatic things they knew. Within a year, its presence felt like a skyscraper had been planted in the valley, and locals literally compared its height to the Empire State Building to make sense of how fast it had climbed. There's a human scale to that story that makes it so compelling. Mountains traditionally feel like the slow work of time, folded by pressure, sculpted by ice. But Paricutin, the volcano that rose from Pulido's field, showed a different face of geology: rapid, violent, and surprisingly intimate. Pulido didn't just read about a mountain in a textbook. He watched it grow from a fissure in his backyard. He saw lava flow, heard constant rumbling, and felt the ash settle on his roof. The eruption lasted years, not centuries. Entire cornfields, homes, and even a church were buried. Communities had to leave what they knew behind. That displacement was immediate and personal. For those families, the mountain wasn't a distant monument. It was loss, spectacle, and a new landscape all at once. Scientists were stunned too. Paricutin became one of the only volcanoes of the modern era to be observed from birth through its full life cycle, and geologists flocked to study it. They watched lava fountains and ash plumes, mapped new flows, and chronicled how a cone of volcanic rock built itself layer by layer. For a generation of researchers, it rewrote assumptions about how quickly new topography could appear. But the most striking part of the story remains the neighbors who lived through it, people who folded their lives around a new smoking presence on the horizon. This idea that a mountain can be born within one person's lifetime is both humbling and strangely hopeful. On the one hand, it's a reminder that the Earth has powers we can't fully predict or control. A quiet field can become a hazard in weeks. What was familiar can be gone by next season. On the other hand, there's something poetic about witnessing creation operate on a human timetable. If you or I were to plant a tree this morning, and decades later that sapling became a place our grandchildren picnicked in, we'd feel connected to a forward-moving story. Now imagine watching an entire mountain emerge in that same lifetime. It makes the time scale of the planet feel more immediate, more connected to our own lives. There's also a strange beauty to the aftermath. the monochrome of ash-covered fields, the stark cone rising out of a flattened landscape, the ruined bell tower of a buried church peeking out like a sentinel. These images are dramatic, yes, but they also speak to resilience. People adapted. Some moved away. Others found ways to live with the new terrain. Over the decades, Parikutin became a place of curiosity and pilgrimage. The very thing that destroyed became for others a landmark to be studied and eventually photographed and remembered. That human reaction is a big part of why stories like Parikutin's stick with us. We don't just remember rocks and lava flows. We remember faces, choices, and the small details. The farmer who kept his walking stick leaning against the house as he watched ash fall. The neighbor who gathered what he could and left with his family. The scientists who set up instruments on the slopes while the volcano was still active. Those are the threads that make the geological event readable to a human heart. So when you hear the phrase, fire-born peaks, don't let it remain abstract. Think of Pulido's cornfield. Think of smoke rising where children once played. Think of a skyline altered in months. Mountains like Parikutin are proof that the earth still writes new stories in fire, stories that unfold within living memory, that intersect with ordinary lives, and that remind us how quickly the ground beneath our feet can change its tune. As we move on, keep that picture with you. A landscape not only shaped by slow patience, but also by sudden, creative fury. A reminder that the planet's history is always being written, sometimes in a single, unforgettable lifetime. Look at any mountain, and you're looking at a palette, sometimes subtle, sometimes shouted across the skyline. Those colors aren't accidental decoration. They're the top layer of a long story. Minerals and chemistry, ancient seas and fires, wind that has been carrying dust for thousands of miles. When you know how to read them, a cliff face can tell you where it came from, what it has seen, and how the world around it has changed. But even without that training, the colors do something else. They make the earth feel familiar, intimate, as if it carries its own memory you can touch. Rusty reds are the easiest to spot. Iron loves to oxidize. Left alone, iron-bearing minerals turn red, orange, or deep brick brown as they react with oxygen and water. Walk into a canyon rimmed in red walls, and you're seeing iron's slow handwriting. I remember the first time I stepped into a red-walled valley. Sunlight warmed the stone, and the whole place felt like walking inside a kiln. It's visceral. The red is a record of oxygen and time. It often means sediment laid down in open air or shallow oxygen-rich water where iron could rust. To a geologist, that's a clue. To the rest of us, it's warmth, it's desert, it's home. Greens show up when copper is involved. Think of that classic verdigris on old copper roofs and statues, nature's own green paint. Mountains that host copper deposits weather into bluish greens and turquoise streaks. Not only beautiful, but useful. The color can mark places that once had hot, mineral-rich waters moving through cracks in the rock, depositing copper and other metals as they cooled. On a cloudy day, those greens look jewel-like. On a bright day, they can catch your eye from miles away, like an unexpected oasis painted into otherwise neutral tones. Pale cliffs, the creamy whites and beiges, often come from limestone. Ancient seabeds turn to rock. Those sun-bleached faces are pages of an old ocean. Shells, microfossils, and lime mud, compacted and solidified over eons. I love standing at the base of a pale cliff and thinking of it as layered history, each stratum a chapter of marine life, climate swings, and shifting coastlines. The pallor also has a texture in light. At dawn, they seem almost translucent. At noon, they glare like blank paper. That palette carries a different feeling. Calm, slow, and somehow monumental. Volcanic slopes have their own dramatic signature. Basalt and volcanic glass give you black, thick, matte, sometimes shiny fields that absorb light and make shadows look deeper. But volcanic landscapes aren't only black. They can gleam gold when sunlight catches mineral crystals like olivine, or when flecks of pyrite wink in the rock. In some places, you'll see black rock mottled with sparkling, warm tones. That contrast, onyx black and sudden gold, feels raw and elemental, like the earth reminding you it can be both destructive and spectacularly beautiful at the same time. Deserts are where color becomes subtle and surprising. Sand isn't just sand-colored. Depending on the parent rock and the mix of minerals, dunes, and badlands can shimmer in rose, orange, violet, and even near purple. Those purples often come from manganese or particular iron compounds in shales and clays. Sunset on a desert ridge can turn the whole landscape into a watercolor of soft pastels and intense streaks. Rosy pinks in the lower slopes, deeper mauves where the light grazes folded rock. Once, hiking through a canyon at dusk, I watched a whole slope shift from beige to purple in 10 minutes. It was like the earth blushing. There's another layer to color that most people don't notice until they see it. Snow isn't always pure white. Snowfall can carry dust from continents away. Saharan dust passes over the Atlantic, coats the Alps, and leaves a thin, rust-colored film on glaciers. I've stood on a ridge and brushed my gloved hand along the surface to find a faint red dust. An invisible connection between two landscapes thousands of kilometers apart. Snow can also turn pink or red because of microscopic algae, an almost poetic reminder that even frozen places have life and color. Weathering and biological life play a huge role too. Lichens and mosses paint rocks with yellows, oranges, and chartreuse. They breathe life into otherwise barren stone. On coastal cliffs, salt spray and organisms add subtle pastels. On older buildings, stone takes on a patina of time, grays deepen into blues, corners soften, and walls wear the lived-in colors of weather and hands. The next time you walk through a city square, look for the local stone in monuments and buildings. The color often tells you what was available in the nearest quarries, and therefore a little about the economic and geological history of that place. For geologists, these colors are diagnostic tools. They read iron oxidation states, mineral assemblages, and depositional environments. Red beds suggest oxygen. Green may suggest reduction or copper alteration. Banded whites hint at carbonates. Blacks imply volcanic or organic rich materials. But you don't need to be trained to enjoy this. There's an emotional shortcut. Color ties you to place. It triggers memories, childhood hikes, a drive through a colored canyon, the way mountains looked at sunset during a road trip. It gives landscape identity. A region with a signature color becomes easier to remember and easier to love. Colors also change with scale. A pebble you pick up might be streaked with the same rusty vein that paints the neighboring cliff. The micro and the macro echo each other. That continuity makes you feel connected, like you can hold a tiny piece of the whole mountain in your palm. I still carry a small stone from a place that made me fall in love with hiking. Its faint green streaks are a private postcard from that ridge. And there's a human layer. Artists and builders have always used local stone as a palette. Think of cathedrals built from golden limestone that seems to glow at dusk, or entire towns constructed with rosy sandstone that gives streets a warm, almost cinematic quality. We pick up color cues unconsciously. Places with warm stone feel welcoming. Cool gray cliffs feel austere and dramatic. That's not accidental. It's how we've been wired to respond to the natural world. So next time you're out, on a roadside overlook, a coastal walk, or standing under a looming cliff, take a moment to watch the colors. Tilt your head. Squint against the sun. Run your fingers across a weather-smoothed stone. Try to imagine the processes that painted it. Oceans that once covered this land. Fires that once poured lava across it. Winds that ferried dust across continents. Even if you don't know the mineral names, the colors are a readable life story. They're Earth's memories made visible, and if you let them, they'll become yours too. Picture yourself halfway up a ridge, boots sinking into wet soil, the air tasting faintly of earth and green. Below, a valley wears a soft white blanket of cloud, its edges clinging to the craggy teeth of the peak like cotton, pulled tight by invisible fingers. Above you, the sky is clear and cold. That patchwork, cloud-draped slopes beside bright, dry summits, is not coincidence. It's the handiwork of mountains shaping the atmosphere itself. Air moves like water when it meets a barrier. Moist air sweeping in from an ocean doesn't just stop at a coastline. It rises. As it climbs a mountain slope, the pressure drops and the air expands and cools. Cooler air can hold less water vapor, so the moisture condenses into droplets. Clouds form along the flank, and if there's enough moisture, those clouds spill their contents as rain or snow. This process, called orographic lift, is what makes one side of a range lush and green, while the other side sits in a dry, clear silence. You've probably experienced this without realizing it. Think about the last time you drove over a mountain pass. On the windward side, there might have been drizzle, fog, moss on the trees. 10 miles later, on the leeward slope, the sun might be out and the grass brown. That abrupt change in weather, sometimes in the span of a single hairpin turn, is the mountain saying where the water will stay and where it will go. On the global stage, these small-scale acts of moisture choreography create enormous consequences. The Himalayas are a dramatic example, an immense wall that redirects the Indian Ocean's moist monsoon air. Every summer, warm, moisture-laden winds race northward. They slam into the Himalayas, rise, and unload one of the planet's great seasonal rainfalls across South Asia. The timing and strength of that release, the monsoon, shape the lifeblood of billions. Farmers listen for its arrival. Festivals and daily routines are tethered to the rhythm of those rains. When the monsoon is generous, crops thrive and reservoirs fill. When it falters, people feel it in food prices and water shortages. Flip to South America, and the Andes perform their own sculpting. The Atacama Desert along the western edge of the Andes is famously one of the driest places on Earth, with stretches that haven't seen measurable rain in decades. Why? Moist air coming off the Pacific is forced up the western slopes of the Andes, dumps its moisture over the highlands, and descends on the western side as dry, warmed air. That descending air has already been cleaned of its humidity. It creates a rain shadow where cloud cover and precipitation are scarce. The result is a stark landscape of salt flats, windswept plains, and a silence so deep you can hear your own breath in the night. This push and pull, moist air up, dry air down, happens on ranges everywhere. The Cascades in the Pacific Northwest catch storms from the ocean, leaving lush temperate rainforests to their west and drier grasslands to their east. The southern Alps of New Zealand bathe the western coasts in rain, while the eastern plains remain relatively arid. Even smaller hills can throw their own local weather patterns into relief. I've seen neighborhoods a few miles apart where one side is consistently foggy and the other basks in sun, just because of the angle of a ridge and the direction of the prevailing wind. There's a human side to all this that's easy to overlook. Where mountains cause steady rains, civilizations often flourish. Terraced rice fields cling to wet hillsides in the shadow of monsoon-swept ranges. Where mountains cast a rain shadow, water is a rarer commodity, and communities adapt with ingenuity. Coastal fog harvesting, deep wells, or cultures organized around scarce, precious water sources. Architecture, agriculture, even folklore can reflect these long-standing relationships with mountain-made weather. In some mountain towns, the smell of wood smoke and the rhythm of roof gutters tell you more about the seasons than any calendar ever could. And it's not only precipitation that mountains control. As air descends on the far side of a range, it warms, sometimes violently, creating strong, dry winds that can suddenly change the feel of a place. These Foihan or Chinook winds can melt snow rapidly, raise temperatures by tens of degrees in hours, and increase wildfire risk. I remember standing in a valley where a Chinook rolled in like an invisible hot wave. One breath of air felt like stepping from winter into spring. Farmers, pilots, and firefighters watch those wind forecasts closely. A fast, dry wind can be a boon for spring thaw, but a threat during drought. Mountains also carve microclimates. A south-facing slope might bask in sunlight and warm faster in the morning, favoring vines or olive trees, while a shaded north-facing ravine holds snow into late spring and shelters species that require cold. Those microclimates define what can grow where, which crops a community can rely on, which animals can make a home, and what schedules people keep. Hikers learn to pack both sunglasses and rain gear in the same trip, because a few thousand feet of elevation can switch conditions from sun to storm. One striking truth about mountains is how quietly powerful they are. They don't move like oceans, but their presence forces the atmosphere to reroute, rise, cool, and release. They turn invisible currents into visible weather. They establish borders not drawn on maps, but written in rainfall and vegetation. A green flank here, a parched plain there. It's a reminder that the planet's systems are intimate and connected. Geography and air interacting to make the climates we live in. And right now, that intimate connection matters more than ever. As global temperatures shift, patterns of moisture and wind are changing in subtle and not-so-subtle ways. Mountain-fed monsoons may arrive early or late, or carry different amounts of water. Snowpacks that traditionally acted like natural reservoirs, holding winter water and releasing it slowly through spring and summer, are melting at different times, affecting downstream cities and farms. People who have relied on predictable mountain weather for generations are being forced to adapt. So the next time you see clouds clinging to a peak, or step out into a sun-drenched valley 1 mile from a rain-drenched woods, remember the simple physics behind the scene. Air rises, it cools, moisture condenses, and the mountain decides who gets the rain. Those ridges and summits are more than scenic backdrops. They are active agents, shaping where water falls, where life can flourish, and how communities must plan for the future. Mountains make weather, and in doing so they help write the stories of the people who live in their shadows and on their shoulders. Life here doesn't change all at once. It steps up, one narrow band at a time, green valley, scrub, alpine meadow, then bare rock, and finally the snow line where the world looks like someone rubbed chalk over the bones of the earth. If you think about a mountainside as a building, every 100 or few hundred feet is a new floor with its own tenants and habits. I like to imagine walking up that staircase and meeting the neighbors on each landing. Start low, and you notice the quiet, patient things first. Patches of moss and lichen that look like old, living paint clinging to stone. They are not decorative extras. They are the pioneers. Where soil is thin or absent, they hold moisture in their tiny tissues, trap dust in organic bits, and slowly make the rock into something softer that can hold a seed. Close your eyes and you can almost feel them. Velvet, damp, stubborn. Film a tight macro shot here and you'll see a miniature world. Dew catching like tiny lanterns, minuscule channels moving moisture, expiration and renewal played out in a square inch. Those simple organisms teach us something about endurance, how being small doesn't mean being weak. Move up a little, and the stones become houses for pikas. If you haven't heard a pika before, imagine a high-pitched tinkle, urgent and bright, pinging across the talus. They are members of the rabbit family, but they live in the gaps between boulders, packing themselves into rocky crevices like secretive old people in a crowded city. I once crouched still for an hour, and the pikas treated me as background scenery, whistling, darting, carrying tiny bundles of grass to their winter pantries. They don't hibernate, they harvest. Watching a pika is watching commitment, a small animal preparing in midsummer for a winter it will never see. There's a fierce dignity to that. Up here, survival is an everyday chore, not an emergency. Higher still, and the air thins. If you've ever hiked into the high country, you know that breathing becomes a deliberate act, slow, deep, a negotiation. But for yaks, this is just Tuesday. Stocky, bowed-legged, with shaggy coats that swing in the mountain wind, yaks are built for this edge-of-the-sky world. Their lungs and blood are tuned to make the most of every thin breath. Their thick fur is a walking thermal blanket. More than once I've been warmed by the presence of a yak herd, by their steady breathing, the swish of their tails, the way they gather low against a ridge, a living wall against the cold. They move through the mist with the weight of old mountain stories, and shepherds who tend them are as much a part of that story as the animals themselves. And then there are the hunters of the high places, the snow leopards. If you've only seen them in a zoo, you've missed their real magic. Up here, they are ghosts, pale as a dusting of new snow, moving like smoke across a skyline. Their bodies are compact, limbs built for powerful, silent leaps, their tails long not just for balance, but as a wraparound blanket on cold nights. Spotting one is a lesson in humility, a fleeting curve of movement, an impression of presence rather than a show. I remember the day a guide whispered and pointed to a ridge where nothing seemed to be. We sat with the wind and the mountains, and slowly, as if summoned by patience, the leopard unfolded itself from the rock, an apparition that drifted, hunted, and then melted away. There's a cruelty to their efficiency, but also a beauty. In landscapes where opportunities are rare, predators are precise. Not all high mountain lives are big or fierce. Some are delicate and almost impossibly adapted. There are frogs that never see sunlight the way we do, species that live their whole lives inside the cloud belt, in a world of perpetual mist. These amphibians have adapted to constant moisture, to a sky that is more often a curtain than an expanse. Their calls are muffled by fog. Their skin drinks the air. Imagine making your home inside a cloud. You'd learn to use every drop of water, to time your breathing with the heartbeat of the wet season, to live in a place where visibility is measured in feet, not miles. To stand in that fog and listen to a chorus of frogs is to hear life insisting on its own terms. Even the smallest lives can be travelers. Butterflies in these mountains are seasonal nomads, moving thousands of feet up or down the slope as the seasons turn. In spring they climb, a fluttering convoy riding warm thermals toward alpine meadows newly freed from snow. In autumn they descend to warmer valleys, following the same invisible lines of weather that we feel but can't touch. I once watched a cloud of butterflies ascend like a living ribbon along a sunlit ridge, the light catching their wings in 1,000 flashes. It felt like a message. Life doesn't just endure here, it moves, it negotiates. It chooses where to be when the world shifts. What ties all of these lived experiences together is a set of strategies, behavioral and physiological, that turn scarcity into possibility. Where food is scarce, animals hoard or time their reproduction. Where air is thin, blood and lungs change. Where temperatures swing from brutal cold to deceptive warmth, fur, feathers, or metabolic tricks create microclimates around bodies. And where the weather is dominated by fog and wind, organisms learn to harvest moisture from the air itself. These are not just survival tactics. They are forms of intelligence, small and specific to place, that have evolved over generations. There is a human lesson folded into these stories. When you've spent time with people who call high places home, herders, village elders, children with cheeks like wind-burned apples, you realize the difference between romance and intimacy. People in the high places do not romanticize the wind. They read it, predict it, live by it. They make alliances with the mountain, timing their crops, moving their animals, making their homes into shelters that teach young ones how to live light and strong. I remember a woman showing me a small stone pile outside her house where she left offerings for those who came with the storms. It was practical and sacred at once. The same pragmatic reverence you see in a Pika's hay pile lives in the hands that stitch yak blankets, in the eyes that search the horizon for a snow leopard's ghost. Cinematically, this is a place for contrasts. Extreme close-ups of lichen and dew, the intimate choreography of pikas moving through rocks, set against the sweeping panoramas that make you feel a little vertiginous. Sound design is crucial here. The whistle of a pika, the hush of cloud passing like a curtain, the low bell of a yak, the barely audible pad of a large cat. These details draw you in because they are human-scaled. We know the sound of breath, of small wings beating, of a footfall in gravel. They make the vastness accessible. And finally, there is the stubborn, everyday bravery of it all. In movies, we celebrate heroes for one bold act. Up here, heroism is a daily grind, finding food beneath the snow, keeping young ones alive through the first thin winter, migrating with the seasons, shrinking and stretching your life to fit the floors of the mountain. It's quiet, it's relentless, it's ordinary and therefore extraordinary. Even where the air grows sharp and blue, life endures. Small, fierce, and unafraid. When you stand near a glacier, the first thing that hits you isn't the cold, it's the scale, the slow, inexorable movement that somehow feels alive. Glaciers move slower than time itself, yet they flow. Imagine a river that behaves like stone most of the time and like water when it needs to, solid enough to carve mountains, fluid enough to slide, fold, and sigh. That tension between stillness and motion is what gives them their voice. On my first visit, I expected cracking and thunder. What surprised me was the low, almost human quality of the sounds, deep, drawn-out tones that seem to come from under the world. Some of that comes from how glaciers interact with the earth. As tons of ice press down, the base of the glacier can melt and refreeze, creating a thin film of water that acts like a lubricant. The whole mass creeps forward, inches or meters a day, grinding bedrock into a fine powder called rock flour. You can picture it, millions of tons of ice, patient as a sculptor, slowly sanding a mountain into gentler slopes. Not all glaciers behave the same. A few surge forward at a surprising pace, faster than you can walk, driven by internal stresses and meltwater channels that suddenly lubricate the base. Others have hardly moved in millennia, preserving layers of snowfall like pages in a book. Those layers trap tiny bubbles of ancient air, snapshots of the atmosphere from thousands of years ago. Holding a piece of that ice in your hand, if you could, would be like holding the breath of a different century. Scientists literally draw those bubbles out and read the air. Concentrations of carbon dioxide, methane, dust from volcanic eruptions, pollen from long extinct forests. It's a kind of time travel that links our present directly to the planet's past. And then there is the singing. When the layers inside a glacier shift and compress, the snow and ice don't simply crack, they resonate. Picture a cathedral pipe organ, but enormous and subterranean. The long, slow notes are produced by columns of ice vibrating against each other, by trapped meltwater channeling through tunnels and cavities, by the compression and release of air held in tiny pockets. These sounds are often too low for us to fully register, more felt in the chest than consciously heard. When they do rise into an audible range, they spill across valleys in a way that makes the landscape itself seem to be speaking. If silence has a sound, this is it, a kind of focused hush, threaded with deep, rolling hums. On some mornings the glacier is coy, only a faint, steady background tone that blends into wind and distant bird calls. On other days, especially when the sun warms the surface or when overnight freeze-thaw cycles rearrange the internal structure, the glacier will sing more boldly. You'll hear long, mournful moans, sudden metallic twangs as thin ice layers snap and reverberate, and a percussive clatter when a sérac collapses. These are not random noises. They are the glacier's responses to stress, to heat, to gravity. Standing there, you start to interpret the sounds the way you might read the cadence of a human voice. Urgent here, contemplative there. I remember the exact moment a glacier's voice became personal to me. It was late afternoon, the kind of light that turns everything sapphire. I stood on a moraine, boots sun-warmed, and watched a blue ribbon of crevasse unfurl like a sleeping thing opening its eyelids. A soft, low hum rose from the ice, so seamless with the light and the air that I felt as if the glacier was acknowledging me, whispering a secret I had no vocabulary for. The hairs on my arms prickled, not from cold, but from the intimacy of that sound. It made me think of our own smallness, yes, but also of continuity, that slow, glacier-time rhythm that exceeds a human life, but nonetheless affects every life downstream. That intimacy is part of why glaciers are so compelling to people. They are archives and oracles. The trapped air bubbles tell us what the atmosphere tasted like before industrial times. The layer of volcanic ash cuddled inside the ice records cataclysmic eruptions that reshaped climates and civilizations. Even the rhythm of melt and flow communicates seasonal stories, when winters were harsh, when summers were warm. For communities downstream, the glacier's song can be literal. Changes in flow alter water availability, and the timing of melt can make the difference between a bountiful growing season and drought. But listening also brings a responsibility. The glacier's voice is changing. The notes are shifting as temperatures rise and melt patterns alter the internal plumbing of the ice. Channels that once opened only in late summer now run earlier and with more force. Crevasses widen. Calving becomes more frequent and louder, a sound like distant artillery to some, a violent punctuation mark to the mountain. Where the glacier used to hum long, sonorous notes, there can be abrupt, more chaotic sounds, signs of a system under stress. You don't have to be a scientist to feel the implications. Think of it in human terms. Imagine if your family's oldest album started warping, the grooves shifting, the songs distorting. It would be eerie. With glaciers, those albums are the planet's climate history. Listening closely, attuning to the low tones, the snags, the abrupt silences, lets you hear not only beauty, but also warning. Practical note: if you ever go to listen, do it with respect. Glaciers are dynamic and unpredictable. Hear the distant hum from a safe vantage, a moraine ridge, a marked trail, or from a boat if you're near a fjord. Let the sounds do their work. Let them ground you in a scale that outlasts any single life. Bring a windbreaker, binoculars, and patience. Sit. Close your eyes and notice which sounds are near and which are far. Try to feel the low frequencies in your chest. Count the beats between groans. Let the rhythm slow your breathing. In that stillness, the glacier's song becomes less like a spectacle and more like a conversation. In the end, the songs of ice are both literal and metaphorical. They are the audible outcomes of physical processes. Yes, but they are also reminders. Songs of patience, persistence, and change. These slow rivers of solid water teach us something about time, that the planet can move and yet remain, that things can be both gentle and relentless, and that listening deeply can reveal histories we otherwise miss. When you leave, the memory of the hum lingers. It's like returning home with a new tune in your head, one that asks you to remember, to act, to treasure a music that is both ancient and alarmingly fragile. Sometimes on a high ridge, when the wind has cleared my head and the world below looks like a patchwork quilt, I crouch down and run my fingers over a rock face. More than once, that motion has stopped me cold. There, etched into the limestone, is the curved imprint of a shell or the honeycomb of fossilized coral. It feels wrong at first, a seaside thing up here in the clouds, and then it becomes impossibly, wonderfully right. Those shells and corals are not jokes the mountain is playing. They are evidence. Long before these peaks were peaks, they were gentle seabeds where tiny animals lived, died, and were buried in mud and sand. Layer upon layer of those sediments turned, over millions of years, into rock. Then the slow, patient violence of tectonics began to push. Continents shoved against continents, and whole floors of ocean rose, carrying with them the mineralized remains of creatures that once filtered water and chased plankton. The Alps, the Himalayas, both are carpeted with that memory. Walk a few hours up many alpine passes, and you'll find reef fossils in rock that now feels like jawbone. Climb in the Himalaya, and climbers and geologists alike have pointed out ammonites at 5,000 meters, spirals that belonged once to creatures of the deep. It helps to picture the process in human terms. Imagine a library where each shelf is a century. Books, the shells and skeletons of small sea animals, get shelved and then slowly move. Over eons, the shelves get stacked and compressed, and then someone bangs into the shelf so hard it tips up on end, and the books are suddenly on a wall that faces the sky. That someone is the slow motion of plates. India smashing into Asia, Africa ramming Europe. The rocks don't fly up. They ride a tectonic conveyor and fold, buckle, and rise, sometimes getting squashed so hard that their fossils are distorted, sometimes preserved like a pressed leaf in a book. Finding a seashell on a summit is a small, tactile miracle. I remember holding one, damp with sweat and a little snowmelt, and feeling dizzy not because of altitude, but because of time. The hands that once crafted that shell belonged to an animal that lived before mammals, before trees, before the first true birds. Yet that tiny mark was right there, no different to hold than the pebble I'd pick up on a beach. For a moment, the mountain and the sea felt like the same place, only separated by a calendar you could barely imagine. That shift from ocean to mountain is also a story about change that's bigger than geology. It's a reminder that landscapes, like people and societies, carry their histories with them. The stone under our boots is a palimpsest of environments: warm, shallow seas, river deltas, deserts, glaciers, each one riding over the last, but never quite erasing it. When you run a palm across a fossil, you're reading an old sentence of Earth's biography. It asks something of you: to slow down, to recognize that the solid-looking world is constantly being rewritten. So when you next find yourself near a ridge or a rocky outcrop, don't rush past. Look. You might find a scallop-shaped curve or a tiny spiral trapped in the grain. Hold it, and imagine the slow lift that brought that creature to the clouds. That echo of the sea is not only a geologic truth, it's an invitation to consider how everything around us has been transformed, how even the most permanent seeming things have a story of becoming. Every mountain remembers the sea. Every stone remembers its own long, improbable journey. Stand at the base of any great mountain, and something in you notices the difference. The air feels different. The light is sharper. Conversations grow quieter. We don't just look up at rocks and ice. We look up at meaning. Across time and across continents, people have done the same. For the Greeks, Mount Olympus wasn't merely a peak. It was the home of the gods, a place where human rules softened and divine arguments could be heard like distant thunder. For Hindus and pilgrims from many traditions, Mount Kailash sits at the center of the world, an axis mundi around which the cosmos seems to turn. In the Andes, the Inca built shrines on high volcanic summits, convinced that the highest points of the landscape were the closest you could come to heaven. These stories are not just old postcards from faraway cultures. They're mirrors. Maybe you felt it yourself. The hush that settles when you reach a ridge, the little rush of vertigo as the valley falls away, the silly but human impulse to bow or to whisper. I remember hiking up a rainy mountain trail years ago and finding a small weathered altar tucked against the rocks, a handful of faded flowers, a scrap of cloth tied to a twig. I didn't know which god or ancestor it honored. I only knew that, in that exact moment, the mountain was also a place of witness. I felt seen in a way I rarely do in the city. Different societies gave different names and rituals to that feeling, but the shape of the idea is remarkably similar. Mountains are thresholds. Mount Olympus is where gods eat and quarrel and watch human folly. Mount Kailash is circled by devout pilgrims who believe that walking its base washes away sins and turns destiny. In the high Andes, each major peak was an Apu, a spirit both protective and demanding. The Inca left offerings on summits because they believed the mountain's tip touched the sky, and from that meeting place, favors, omens, or even messages could be exchanged between Earth and the beyond. Archaeologists have found tiny, exquisitely preserved mummies on some of those summits, reminders that people once believed sacrifice and reverence at altitude could alter the fortunes of an entire valley. What's striking is how personal these practices are, even when they're part of grand cosmologies. Pilgrims who circumambulate Kailash often describe the walk as a conversation, not with a distant, abstract deity, but with the mountain itself. Families in Andean villages make annual offerings to local apus before planting season. The old woman stirring coca leaves at a roadside shrine is not performing faith as doctrine, but as relationship. The mountain, in these moments, is less an object and more a being with whom you have to keep terms. That relational quality helps explain why mountains inspire both awe and responsibility. When a community believes that a peak is alive, it tends to treat that peak as a neighbor. Conservation, ritual taboos against needless cutting or mining, and the careful stewardship of sacred waters are often part of the same cultural package. Conversely, when outsiders dismiss or exploit these places, it's rarely just ecological damage. It can feel like a wound to a living entity, and to the people whose lives are woven to it. There's also a moral dimension to climbing. Think of the hero's ascent in myth. It's rarely about reaching a summit for the glory of a view. The climb is a test, a path to transformation. The weather strips away pretenses. The thin air clarifies priorities. Standing on top, many tell of a small but radical reordering in their hearts. Fear replaced by humility, a sense of smallness that somehow makes room for larger purposes. That's why people have used mountains as places to seek answers, to fast, to pray, to negotiate with fate. And then there's the plain beauty of the metaphor. Mountains rise. They refuse to be only horizontal and mundane. If rivers are the body's veins, carrying life across the land, mountains are the spine, upright, bearing weight, pointing toward the sky. Perhaps that's what mountains are, the Earth's way of reaching for something greater than itself. So when you next find yourself looking up at a peak, or even at the slope of a long city hill, notice what stirs in you. Is it curiosity, fear, reverence, or a longing to be better than you are? Those responses are the continuation of a very old conversation between humans and the high places of the world. In the next section, we'll follow one of those conversations into the lives of people who still hike, circle, and celebrate these sacred heights, and see how those practices shape modern identity, politics, and the landscapes we share. Higher still, the air thins, and the world narrows into a ribbon of stone and sky. Imagine stepping out of a low cloud and suddenly finding a place of worship, perched like a bird's nest on the cliff face. Not built for tourists, but for people who once walked for days across screaming, blue-tinged glaciers to get here. These are the temples in the clouds, and their story is one of faith measured in frostbite and breath. Picture a small group of pilgrims centuries ago. They move slow and deliberate, shoulders hunched against the wind. Their boots crunch on old snow and ice, each step a promise. They are carrying what little they can spare: a handful of grain, a small bar of gold wrapped in cloth, or a simple bundle of prayers tied on a stick. For them, the path itself is an offering, each bruise on the hands, each frozen tear, a currency of devotion. What I love about these journeys is how ordinary they are, despite the heroic setting. You don't have to be a saint to understand why someone would take that risk. When you lose the noise of daily life, the bills, the notifications, the chatter, the mountain offers a kind of clarity. You see what's essential: warmth, company, the next foothold, and the reason you left home. For many pilgrims, the reason is devotion. For some, it's penance. For others, hope. The mountain doesn't care which. It only demands that you keep moving. Monasteries cling to these cliffs the way barnacles cling to a ship. They look precarious from the valley below, but from the inside, they are steady and contained. A circular rhythm of work, chant, and tea. The rooms are sparse. The altars are simple, often warmed by butter lamps. The architecture itself seems to have learned humility. Low doorways to bow you, narrow windows to focus your sight on what matters. Here, altitude becomes a spirit rather than an obstacle. Faith has always followed altitude because altitude strips everything else away. I remember visiting one of these cliff monasteries on a stubbornly clear morning. I arrived breathless, not just from the climb, but because the place asks for a small renunciation: your hurry, your certainty. An old nun smiled at me, handed me a string of prayer flags, and said, "Tie one. Let the wind do the remembering." That simple act, my flag fluttering with countless others, felt like turning my small anxieties over to something vast and patient. It was a relief that didn't require proof, only wind. Prayer flags are the loudest language up here. Each square of cloth is a sentence. Wishes for health, for safe passage, for rain, for peace. They fray and fade, and that's the point. Their meaning is in letting go. The prayer is released as the fabric wears thin. Standing beneath them, watching colors tumble into the sky, you sense the continuity between people who lived here 1,000 years ago and strangers who pass through today. The flags don't ask for attention. They only ask to be seen by the wind. These places also hold ordinary human stories. A monk who lost his brother and found peace in the ritual of sweeping the courtyard. A woman who came every year to leave a spoonful of chang as thanks for a healed child. A young father who, out of reverence or desperation, hung a small carved yak bone on a doorpost. For all the grandeur, the details are domestic. Offerings are practical. Food to feed the monks, coin to pay for prayers, sometimes a toy left at a shrine by a grieving parent. Those gestures bridge the gap between the sacred and the everyday. If you ever stand in a monastery courtyard and look down over the valley, you might feel the same curious, almost inconvenient tenderness I felt. That faith can be stubborn and surprisingly human. It doesn't demand perfect belief, only an honest step. And when you leave, you carry something less tangible than a photograph. A slower pulse, a memory of wind in prayer flags, the echo of a chant that seemed to ask more questions than it answered. Temples in the clouds remind us that devotion isn't always public spectacle. Sometimes it's a quiet act, one foot in front of the other, an offering handed over with both hands, a flag set free to speak to the sky. You step out of the Jeep as the temperature drops and the world seems to thin. The air in your lungs is cool and a little spare. Your skin prickles from the kind of cold that feels almost clean. The sun, instead of soft and forgiving, has an edge to it. It cuts across the landscape with a clarity that makes every rock and ridge look sculpted. Shadows lengthen, black and crisp. Above you, the sky has turned an almost impossible blue, the kind photographers chase with filters but rarely capture in full truth. That sharpness is the first thing people notice up here. At altitude, there's simply less atmosphere between you and the sun. Less air means fewer molecules and particles to scatter sunlight, so the light retains its clarity. Think of it like wiping a fogged window. Colors gain contrast, outlines sharpen, and the blue overhead runs deeper because less of the shorter wavelengths are being diffused. It's a very physical reminder of how much the air does for us at sea level. The veil that cushions and softens our world is lifted. And when the veil lifts, astronomers notice something else. The stars don't dance as much. At low elevations, starlight has to slither through turbulent, moist layers of air. Those layers shift and boil, bending the light in slightly different directions from one moment to the next. That twinkle, that constant shimmer. Up on a dry, stable peak, the air column is thinner and calmer. Stars burn steadier and clearer, not just brighter. Photons arrive in a more faithful order, which is everything if what you're after is a tiny motion or a faint fingerprint of light. That steadiness is measured in seeing, the technical term for how sharp a point source looks through the atmosphere, usually in arcseconds. Low numbers are gold for observers. The smaller the blur, the more detail a telescope can resolve. A mountain can have that blur. In practical terms, that means we can separate two stars that look like one lower down, or tease out the faint glow of a galaxy at the edge of detectability. It's why the biggest optical and infrared instruments congregate on summits where the air is thin and dry. Walk with me to Mauna Kea in Hawaii, or to the peaks crowning Chile's Atacama. On Mauna Kea, the summit sits above much of the atmosphere at about 4,200 meters. Its slopes are lava and scrub, and at sunset, the observatories, domes and towers gleaming in the last light, look like a scientific city turned toward the heavens. Chile's northern deserts, with their vast aridity and high plateaus, host installations from small survey scopes to the very large telescope on Cerro Paranal and the giant array of dishes on the Chajnantor Plateau. These places are chosen not because they're dramatic, though they are, but because of the quietness of their skies. Dry air matters as much as thin air. Water vapor is an astronomer's nuisance. It absorbs certain wavelengths, blurs infrared signals, and scatters. Places like the Atacama have been sculpted by millennia without rain. The result is an atmosphere with remarkably low humidity. That's critical for infrared and sub-millimeter astronomy, bands of light that tell us about cold dust in star-forming clouds, the atmospheres of exoplanets, and the early assembly of galaxies. At those wavelengths, a few percent more water vapor can be the difference between a clear detection and an ambiguous blip. The technology up there reads like poetry crossed with engineering. Huge mirrors, precise as watch components, collect faint photons and deliver them into instruments cooled to nearly absolute zero. When the remaining atmospheric turbulence is still a problem, adaptive optics steps in. A deformable mirror, controlled hundreds of times per second, flexes to cancel the atmosphere's distortions. Sometimes a laser is fired into the sky to create an artificial guide star, a pinprick of light that the system uses to measure the turbulence so it can correct for it. The image that ends up on the detector is the world's most patient sculpture of light, polished back into focus. The human side of this work is understated but deep. Astronomers and engineers make pilgrimages to these summits. They acclimatize, they respect the thin air, and they learn to take the night slowly. Nights can run long, 8, 10, even 12 hours of observing. You'll find them in control rooms, cups of coffee cold beside their keyboards, watching graphs and images roll in. When a long exposure finally reveals a faint feature, a wispy arm of a distant galaxy, a spectral line signifying a planet's atmosphere, there's a private kind of jubilation. It's less dramatic than a movie scene. It's a quiet, concentrated joy that belongs to people who know how rare photons can be. And there's a softer human experience, too. On clear nights, step outside the dome, or simply stand in a doorway away from the artificial lights, and the Milky Way pours across the sky like a river of milk. You can see the structure of it differently from a mountaintop. The sky feels three-dimensional in a way you don't usually notice. It's easy to say the mountains bring us closer to the heavens, but there's an intimacy to it as well. Up here you feel the scale, your life small, your questions both more modest and more hungry. It's not just about cutting-edge detectors and big data. It's about the urge to look, to hold a little more of what's out there in your hands. Those mountaintop observatories have changed what we know about the universe. From them, we've mapped the motions of stars that revealed the presence of invisible mass, measured the redshifts of faint galaxies that trace the expansion of space, and picked out the tiny wobbles of stars that betray unseen planets. The clarity of a high, dry sky is a kind of amplifier for discovery, not because it returns answers on a silver platter, but because it makes the faintest whispers of the cosmos audible enough to be measured. But there's also a responsibility that comes with building on these places. Many of these peaks are sacred or culturally significant to the people who live in their shadows. Modern observatories have to navigate more than just logistics and weather. They must engage with local communities, listen, and find ways to honor both scientific inquiry and cultural values. The best sites are those where collaboration has grown from respect, where the science becomes part of a larger conversation about place and stewardship. When you think of a mountain as a ladder to the stars, it's easy to slip into metaphor. Yet the physics is literal. Every meter up is a shorter path for photons to our instruments. Every arid night removes a screen that would otherwise mute distant signals. And every human hour spent under that sky brings a little more nuance to our questions. The telescopes high on Mauna Kea, the arrayed antennas on Chajnantor, the parabolic dishes and glass domes across other peaks. They are extensions of our curiosity, installed in some of the loneliest and clearest places on Earth. So the next time you see a photograph of a mountaintop observatory, take a moment to think about that thinness of air. Imagine standing there at dusk as the last warm light pricks the horizon, feeling sunlight that cuts clean enough to make metal and rock glow. Picture the domes opening, a hush taking over, and the stars arriving, steadier and truer than anywhere below. It's a simple exchange. We climb a little, and the universe offers up its subtleties. Mountains don't just raise telescopes, they refine our vision. They teach us to be patient listeners of light, to steward those rare, clear nights, and to remember that understanding the heavens often starts with changing the way we meet them. You've probably stood beneath a mountain and felt like you were looking at something eternal, a shape carved and fixed, patient and unchanging. That's the story we tell ourselves because it's comforting. But if you stayed there long enough, with instruments and time instead of the human heart's quick beat, you'd notice the mountain is breathing. Not with lungs, but with movement. Millimeters, maybe centimeters, shifting over years, decades, centuries. That tiny, steady motion adds up. Imagine you're hiking a ridge at dawn. The air is thin and cold, rocks underfoot hard and unyielding. You press your palm to a weathered boulder and think of it as ancient, immovable. Now imagine that same rock sliding imperceptibly upward a few millimeters a year because the tectonic plate beneath it is still pressing. In places like the Himalayas, the collision between India and Eurasia lifts ranges at rates you can measure in millimeters per year. Not dramatic if you live a lifetime, devastating over geological time. Those millimeters are the raw arithmetic of mountain building. There's a second invisible force at work: weight. Glaciers are rivers of ice that sculpt and grind, but they also press down. Where great ice sheets once lay, they push the crust into a long, slow indentation. When the ice melts, and it is melting in many places right now, that weight is lifted and the ground begins to rebound, like a mattress slowly straightening after someone gets up. This is called isostatic rebound or glacial isostatic adjustment. In Scandinavia and parts of Canada, shorelines are still rising because the land is popping back after the last ice age. In Greenland and Antarctica, parts of the bedrock are lifting as ice mass decreases. It's a gentle, patient upthrust that can be measured with GPS and seen in tilted trees and raised beaches. Those same forces can work in reverse. Some mountains sink, not from erosion alone, but under their own load. As ice accumulates, the sheer mass presses the crust downward. And when glaciers melt, landscapes don't just snap back instantly. They reshuffle. The ocean feels it too. Melting ice changes where water goes and how the crust sits, contributing to subtle, complex changes in local and global sea levels. And then there are the moments when stone stops breathing politely and lets out a roar. Earthquakes are where patient motion meets sudden release. The plates grind, stress builds, and the earth snaps. In the blink of an eye, a valley can be thrust upward, a coastline can fall, and a whole mountain face can tilt. Think of the 2011 Tohoku earthquake in Japan. Entire sections of coastline were lifted by several meters while others subsided. Entire towns found themselves suddenly higher or lower relative to the sea. Those are the times when geological time lurches into the human time frame. Landslides are the other dramatic punctuation marks. They can erase peaks and cleave valleys in moments. In 1980, Mount St. Helens North Slope collapsed in a massive landslide, removing the summit and triggering an eruption that reshaped the mountain in an afternoon. More recently, numerous large landslides around the world, some in remote regions, some tragically close to villages, have shown how quickly a known landscape can be rewritten. One moment, a ridge stands. The next, a town watches a flank of the mountain slide away like a sandcastle under a tide. But let's bring it back to something you might recognize. There's a subtlety to this motion that connects to everyday life. Have you ever felt a tremor and looked up, heart racing, only to see people around you barely notice? That small shaking is the same phenomenon, only in micro. Your phone might buzz with an alert that registers dozens of small slips and nudges you won't feel. Scientists rely on those micro events. They are the whispers that tell the story of the mountain's slow respiration. People often think of rocks as unchanging because human memory only spans decades, and our cities sit on timescales that flatter our sense of permanence. But there are traces, little clues in the landscape that betray ongoing motion. Old docks sitting above current water lines, sea stacks left stranded inland, staircases that no longer match a hill's slope. Those awkward alignments are the handwriting of an active planet. In some places, you can see tree trunks bent awkwardly because the ground under them has leaned. In others, archaeological sites show structures built for one shoreline that now stand well above it. Science has become good at translating those tiny changes into stories our lifetimes can understand. Precise GPS stations dot mountain ranges. Satellites use radar to measure the ground to millimeter precision from space. INSAR, interferometric synthetic aperture radar, can show a mountain breathing across weeks and months, a map of uplift and subsidence rendered in colors on a screen. Those technologies let us see patterns and relate them to cause: plate motion, ice loss, groundwater extraction, even the filling of reservoirs. Humans can, in some cases, nudge this breathing. Damming a valley and creating an enormous reservoir can increase pressure on faults and trigger earthquakes. Our cities and infrastructure add a new chapter to the ancient story. The personal angle is easy to overlook until a shift becomes personal. There are people whose houses now sit in places that were shoreline when their grandparents were young. There are farmers who watch terraces become less effective because the slope below them is sliding. There are climbers who find routes altered year to year by rockfall as permafrost thaws and ice that once cemented cliffs gives way. Mountain guides learn to read this living rock, where to step, what to trust, when to turn back. And that knowledge is the human way of syncing with the mountain's breathing. One of the most human ways to feel this process is to stand near a glacier, listen to its creaks and groans, and consider how that mass is both sculptor and weight. As it retreats, valley floors may rise, nearby springs may change, and the backdrop that has defined a town for generations may thin. For many communities, that's not an abstract geological lecture. It is a change to livelihoods, risk, culture. There's also a poetic comfort in acknowledging the slowness. The mountain's tiny upward climb or the coast's inching retreat is a type of patience, and it reframes our relationship with permanence. It says, scale matters. A human life is a single breath. The earth takes millennia, but those breaths accumulate into landscapes. When an earthquake reminds us that the earth can accelerate its motion into violence, the personal consequences can be stark. The 1964 Great Alaska Earthquake rearranged the coastline dramatically. Some islands were raised by meters, a permanent, visible alteration. For the people who lived through it, the map of daily life changed overnight. Roads, docks, and the relationship to the sea were remade in hours. Moments like that compress geological time into human memory, making the formerly patient motion immediate and urgent. Even if you don't live in an earthquake zone, the mountain's slow breathing matters. It shapes rivers, redirects water courses, alters soil stability, and subtly changes climate influences as elevation patterns shift over long spans. It's part of why certain valleys hold good farmland and why other places remain wild. It is part of the reason that historical maps don't always match modern ones. So next time you look at a cliff, a ridge, or a glacier, consider the timescale you're not seeing. Picture the millimeters stacking into meters, seasons folding into centuries. Imagine a mountain not as a single immovable thing, but as a system of slow pulses, tectonic pressure, ice weight, seasonal thaw and freeze, sudden rupture, and quiet rebound. There's a kind of intimacy in recognizing that your favorite trail, the profile of a local skyline, the pattern of a river, all of them are the result of this ongoing, patient pushing and pulling. The planet is not static. It is a machine humming on long wavelengths, and we live on one of its surfaces, sometimes feeling a tremor, sometimes noticing a shoreline edge that no longer fits the map, sometimes hearing a glacier groan. That awareness, that sense of participating in a world where stone breathes, changes how you think about permanence. It doesn't make things less meaningful. If anything, it makes our moments more precious, because they occur on a stage that's always moving beneath our feet. Cut to shots of a GPS station humbly perched on a ridge, then satellite imagery showing uplift in color, and finish on a slow pan of a glacier edge retreating into a newly exposed valley floor, the mountain's breadth made visible. Imagine standing at the base of a mountain and feeling very small. That feeling of scale, history, and gravity all comes rushing back when you look at mountains beyond Earth, except there the scale and the stories become almost science fictional. On Mars, for example, Olympus Mons doesn't just dominate the horizon, it dwarfs everything we think we know about big. It rises nearly 3 times taller than Everest, and its slopes are so broad they seem to slide gently away until they meet the curve of the planet itself. Picture a shield volcano so immense that, if you could walk around its base, you'd be tracing a continent-sized ripple in the ground. The rim, the shallow slopes, the collapsed caldera, each feature tells a tale of repeated eruptions, slow piling of lava, and a planet whose subdued tectonics allowed a single volcano to keep growing for eons. It helps to make this personal. Think back to the last time you hiked a ridgeline and looked down at the valley you'd crossed. You remember wind, tired legs, the satisfaction of having climbed. Now multiply that by a factor of Mars. There's no wind noise in the same way there, no green trees to sway, but the idea of human footprints dwarfed by a mountain the size of a small country captures that same feeling, an intimacy with scale that makes you both proud and insignificantly tiny. Scientists imagine what a sunrise would look like from Olympus Mons, a long, shallow light that spills across a planet-sized slope. Even if we never set foot there, the image connects to something in us that craves perspective. Then there's Pluto, a world that used to live in our fuzzy category of dwarf and distant, until New Horizons gave it a personality. On its frozen plains lie mountains of water ice that behave like rock because the temperatures are so low, but on the nitrogen glaciers, soft and mobile even in that deep freeze, these mountains can float and drift. That's not metaphor, it's literal. Imagine an iceberg made of water ice, huge and jagged, bobbing across a sea of frozen nitrogen, pushed by slow, almost geological currents. They glide like ancient wooden ships on a black and white ocean, leaving behind trails and collisions that reshape the terrain over thousands of years. To put it in everyday terms, remember a snowball you once pushed across a frozen pond as a kid. The way it might gather frost, scrape the surface, and slowly move when the wind or the current nudges it. On Pluto, those pushing forces are not wind, but subtle thermal flows and the slow creep of volatile ices. The mountains there have stories written in the patterns of drift, in scars where one slammed into another, in the lonely way some stand isolated like lighthouses on the horizon. That strange, slow motion gives these features a lifelike quality, a reminder that mountain doesn't always imply stony permanence. Sometimes it's movement disguised by cold. Travel closer, and you'll find asteroids, small rocky survivors of the early solar system, bearing their own rugged profiles. Don't be fooled by their size. Even tiny worlds carry ridges, peaks, and valleys that were carved or impressed long before life had a chance to tell stories about them. Many of these shapes are the fingerprints of ancient impacts, collisions so violent they reshaped entire bodies, raised central peaks, and threw material into temporary orbit. Vesta, a large asteroid, bears a crater named Rhea Silvia with a central peak nearly as tall as some mountains on Earth. series surprises us with Ahuna Mons, a smooth, dome-like mountain thought to be a cryovolcano, an ice-driven equivalent to earthly volcanic mountains. These features speak to a time when the solar system was a billiard table of rocks, and collisions were the language of creation. That leads to a simple but profound idea. Wherever you find a world, you usually find mountains. They're not random. They are universal monuments carved by gravity and marked by time. Gravity sculpts and time records. On big worlds, with strong gravity and active plates, mountains rise and fall in mountain-building cycles, folding, faulting, and eroding in ways millions of years long. On smaller bodies with weaker gravity, mountains can be much taller relative to the size of the world because the weight of the rock presses down less. They can be formed by the slow accumulation of lava or by sudden impacts that throw material inward and upward. On icy worlds, rock becomes water ice or frozen ammonia, and mountains behave differently. They can flow, float, slump, or stand as stiff monuments depending on temperature and composition. Making this relatable, think of different materials around your house. A pile of wet sand can hold a steep face. Dry flour can't. A frozen puddle is rigid. The same water as steam is impossible to hold. Mountains across the solar system follow similar rules. The material they're made of, rock, ice, mixed rubble, determines how steep they can be, how tall, how quickly they erode or drift. Gravity determines the limits. Time, patience, and repeated processes tell the story of their shaping. There's also an emotional thread to these extraterrestrial peaks. We climb mountains on Earth to feel a certain proportion of awe and accomplishment. We photograph them, paint them, build myths around them. On other worlds, the mountains carry that same ability to anchor a narrative. Olympus Mons is a monument to volcanic persistence. Its scale invites us to rethink what big means. Pluto's drifting ice mountains are almost playful, reminding us that geology can be gentle and slow, as well as massive and violent. Asteroid ridges are the diaries of ancient chaos. Each one invites a human story. What if an explorer stood on that rim? What sonic memories would they carry, if any? What would the dawn look like? The imagination places us there, folding our human desire to explore into the cold facts of physics. And there's a kind of humility in knowing that the laws shaping mountains are the same everywhere. The interplay of heat, pressure, material strength, and gravity produces peaks and valleys, from the tiniest moon to the largest planet. Those same rules that let a raindrop carve a creek into a hillside on Earth also let a comet scar a distant world and lift a ridge where nothing human will ever tread. Mountains, in that sense, are proof of continuity across the cosmos. The same physical poetry at once unites and differentiates worlds. So when you next see a photo of a faraway mountain, an alien skyline against a strange sun, try to remember the personal side of it. Imagine standing there, the smell of nothing, the taste of very thin air or no air at all, and that same human pulse that made ancient people climb hills to look out and tell stories. Those mountains are monuments not only to gravity and time, but to our own curiosity. They remind us that the universe is a sculptor, slow and relentless, and that every world, no matter how distant or small, keeps a record of its own becoming in ridges, peaks, and slopes. Mountains beyond our world are both strangers and kin. They are alien landscapes shaped by physics, and in them we find echoes of the places that made us. Beneath every ridge, the earth keeps working, patient, slow, and faithful. Mountains rise, crumble, and rise again. Every pebble you might kick on a trail once brushed the stars. Every grain of sand was once part of a summit. As you lie here, feel continents drifting over deep time, glaciers carving slow signatures, molten rock cooling in secret chambers below. That hidden motion holds you now. Strength is not stillness, it is endurance. What falls becomes riverbed. What fades becomes fertile ground. The tiny worries you carried today are part of that long process. They change shape, settle, and feed new growth. Let that thought ease the tight places inside. Breathe deeply now. Inhale the patient rhythm of stone. Exhale and let your body melt into the earth's calm. Imagine being cradled by layers of time. Steady, steady, safe. Good night.